I want to prove that the limit as x approaches 1 of f of x is equal to 1 if f of x is equal to x squared if x is not equal to 1, and 2 if x equals 1. So what this looks like is we have at x equals 1, the y value is 2, and everywhere else will just be a parabola. And so at x equals 1, we want that to be 1, so that will be a hole. And because we're looking at a limit, we know that the left-hand limit will have to equal the right-hand limit. So if we look at x equals 2, there's nothing, to the left or the right of it. But if we look at y equals x squared, we know that to the left and the right of it, we can approach a limit here. So we're going to be using x squared for our function. So for x not equal to 1, we're going to be looking at the absolute value of my function minus the limit being less than epsilon. And so the function we're looking at is x squared, the limit is 1, and that's less than epsilon. So that means x squared minus 1 will have to be between negative epsilon and epsilon. And if I add 1 to both sides, we get 1 minus epsilon less than x squared less than 1 plus epsilon. And here I just need to square root all the sides, so we have the square root of 1 minus epsilon less than x less than 1 plus epsilon, all in the square root. So that's our first inequality with respect to x. The second one, we're going to be looking at the absolute value of x minus c being less than delta. C is the x value that we're approaching, so that's just going to be 1. So x minus 1 will have to be between negative delta and delta. So if we add 1 to all the sides, we get 1 minus delta less than x less than 1 plus delta. And now we have two inequalities for x. So we're going to set the smaller bounds equal to each other. So 1 minus delta will equal the square root of 1 minus epsilon. So I'm going to move the delta to the right and move the square root 1 minus epsilon to the left. So we'll have 1 minus the square root of 1 minus epsilon equal to delta. And that's our first delta. For the second delta, we're going to set the upper bounds equal to each other. So that will just be 1 plus delta equal the square root of 1 plus epsilon. And if I subtract 1, delta is negative 1 plus the square root of 1 plus epsilon. Now the last step, we want to be looking at the minimum of the two deltas. The two deltas depend on what epsilon is. And here, it is not obvious which one is smaller. So we're going to let delta to be the minimum of 1 minus the square root of 1 minus epsilon and negative 1 plus the square root of 1 plus epsilon. And that concludes the proof. Okay, for the next problem, we're going to be looking at a similar one, but instead we're going to be looking at a negative x value. So we'll have limit as x approaches negative 2 of f of x is equal to 4 if f of x is again equal to x squared, but here when x is not equal to negative 2, and it's equal to 2 if x is equal to negative 2. Okay, let's look at the graph. At negative 2, we said it's going to be 2. And everywhere else, it's going to be x squared. So we can draw a nice parabola. So at negative 2, we know it's 4. So it's going to be up here. It's going to be a nice circle. So it'll be something like that. So this isn't the best drawing, but you get the idea. And because we're looking at a limit, we're going to be looking to the left and the right of negative 2. And it doesn't make sense to look at this point. So we're going to be looking at the graph x squared from the left and the right. So because we're looking at the graph of x squared, we're again looking at the top function. So if we consider x not equal to negative 2, we'll be taking the absolute value of f of x minus my limit being less than epsilon. My function we said is x squared. My limit is 4. And so x squared minus 4 will have to be between negative epsilon and epsilon. At 4, I get 4 minus epsilon less than x squared less than 4 plus epsilon. And now I need to take the square root. So I have the square root of 4 minus epsilon less than, okay, this is where it gets tricky. So we know the square root of x squared is equal to the absolute value of x. Because what if x is negative? Right, so if you have, let's say, negative 3 squared, you don't say this is equal to negative 3. Because the square root function is always positive. So it always will give us a value that's always greater than or equal to 0. So we would have to instead look at the absolute value of this. So we would have to put the absolute value, which will be 3. So another way to think about this is you can do the opposite of whatever's inside the square root. So this will turn into absolute value of x, and then it would actually be negative x because of what we said on the left. Okay. So once we're clear on that step, what we can do now is multiply both sides by negative 1. And when we multiply by negative 1, the inequality changes. So we'll have a negative over here. So negative square root 4 minus epsilon. And that changes to a greater than x. And then greater than negative square root 4 plus epsilon. And so we have our first inequality for x. Okay, the second one, we're going to be looking at the absolute value of x minus c being less than delta. C is the x value that we're approaching. So if we go up, c was the negative 2 in this case. So we'll have absolute value of x minus negative 2, which will just be plus 2, less than delta. And we can remove the absolute values. We'll get negative delta less than x plus 2, less than delta. And we'll subtract 2 to get negative 2 minus delta less than x less than negative 2 plus delta. And that's our second inequality. Okay. Now what we have to do is set the bounds equal to each other. So we'll set the lower bounds equal to each other. So we have negative 2 minus delta equal to the negative square root 4 minus epsilon. And I'm going to move the delta to the right and the square root to the left to get negative 2 plus square root 4 minus epsilon equal to delta. And then I'm going to set the upper bounds, so the negative 2 plus delta equal to the negative square root 4 plus epsilon. So if I add 2 to both sides, I'm going to get delta equal to 2 minus square root 4 plus epsilon. So now I have two deltas, and I want to find the minimum of the two. So here, we're not exactly sure which one is smaller. So we're just going to say, we're going to choose delta to be the minimum of 2 minus square root 4 plus epsilon and negative 2 plus square root 4 minus epsilon. So the smaller of the two is our delta. And that completes the proof.